Hello. Thank you very much for being here so late. I know you all must be tired, so I'll try to make this a little bit fun, even though it might be my concept of fun, which is like coding related, so it might not be fun for many people. But well, thank you for being here. I will try to be at least interesting. I'll introduce myself. I am a developer for many years. Nowadays I work at Toptal, which is a remote work company. So if you are interested in working remotely, we can probably find a job for you. That said, this is not about work, this is about fun. So hopefully nobody here is a game developer, otherwise they're gonna kill me, because I'm not a game developer, I'm an engineering manager, I am all-around geek, so this is my interpretation of game programming, is seen from a point of view of someone that doesn't really do it for a living. So follow me on Twitter, that's my Twitter handle, and let's start. So, okay. So let's see a little bit the differences between normal front-end development and game programming, because that's where we want to start. So, you know, normally, if you want to do something on a canvas with the normal development, here's what you do, right? So you get the context, you get a canvas, you get a context, and then you write some text on it. As simple as that. You write it once, it's there forever, it's done, right? Right, but you get no animations. So if you want to do animations and stuff like that, you need to have a different overall concept of an application. So you have a game loop or draw loop or main loop as it's called, and it works like this, right? So you have a function that draws whatever you want to have, and you call it every frame. So the whole screen is redrawn every frame. You control everything that is on screen. Every frame starts from a blank screen. And if you look at this line here, you know, it just clears everything, literally clears the whole screen every 30th of a second, and then you redraw everything. So it may sound like we are doing a lot of work. We are doing a lot of work, but animations come really, really easy, and you will see as we build on top of this that writing the games becomes like truly, truly easy. So the way to do this is, again, using this API call, which is a request animation frame, which is a JavaScript API that gets called every time a frame, so a frame of your game has been printed, so you can take some time, calculate it, and then it gets printed again. And so this is basically how it works, right? So every 30 milliseconds, you clear, you redraw, and you go back. And to give you an example of that, we have the code, so, and we can get started. This is the same code as it is in there. There is a canvas, 640 by 480, and the same code there. So if I load this in, here we go. Yeah, as you can see, we already have a small animation, right? So the 2 digits here are the last 2 digits of the milliseconds of the ticks. So just to show that there is some difference there. But here it is, right? So it's as simple as that. 5 lines of code, you already have your first animation. Moving on, what's the next step? Well, the next step, you know, is Sprites and Assets, right? So nice things that we want to print on screen. And as you can see here in the code, so this is an example of a very simple animation. Is slightly more complicated than the one it was because we are moving around the writing, right? So if I copy this code here and just put it in my basic loop, then I will probably have this, yep. So we can load it up. Right? And so it's the same thing, just with a, you know, with the writing moving around. As you can see, just by changing the way I print it every frame, I have an animation that's like totally free. That's why we use this loop. animations are trivial. But anyway, so the code looks like this, right? So what you have is a first setup bit here, the first 3 lines, in which you get the canvas and set up the font. Most importantly, we have an update phase in which you recalculate all the data that you need in order to generate the frame. In this case, recalculate the position. And then in the second bit, there is a draw part in which you clean the screen and then reprint everything. So it makes sense if we create a class around these two parts, so we can have more and more sprites, right? So what you can have here is something like this, a class sprite. It has a constructor that does initialization, and then an update method that takes ticks and recalculates the position, and then some data for draw. I didn't make a method for it, and you will understand why quite soon. So once we introduce that class, as you can see, the code is already looking much simpler. There is, hello is a new sprite, and hello updates every frame, and then you draw it, right? And thing is, of course, that this is still a little bit dirty. There is still some calculation in there and some things. So we introduce a new concept, which is assets. What are assets? Assets are, let's say, the part of the sprite that actually does the drawing. So the sprite contains all the metadata, if you like, of your spaceship, but your spaceship pixels are inside the assets. Why is that? Well, the reason is very simple. We want to save memory. So if you have 1 million enemies, they all look the same. You want to have one asset shared by like a million different sprites, and not having so many copies of that. So that's why the draw is inside the asset here, and is passed here, so we can have one single. So the sprite knows how to draw itself at the end of the day, which is a good thing to have. And if we do this, we can look at the code, and the code now has a sprite and has a draw, and that's it. And if I run this, it's still going to look exactly the same as the one that we had before, so I'm not really bothering showing it to you. But let's do something more interesting, right? So with assets, we can do more interesting sprites. And okay, so this is the same with assets, but we can do more interesting things like this, right? So we can have a sprite again, and that just moves left to right. As you can see, the update just changes the x coordinate, increases it by 5 every frame, and then wraps around. And what is the draw part? Well, the draw part gets a suspicious Mario.png image, and what it does, it just copies that image over to the specific point that my sprite points to. And it does that every frame. In fact, that image, if you want to look at it, is this one. Well, it's a bit small. Let's make it bigger if we can. Apparently not. Okay, here we go. So it has 3 frames. So what it does, what the draw does, is one frame is going to take the first third. The second frame is going to take the second third, and the third time is going to get the last third, and so you get a small animation. And so if we go look at this, what we get is Mario walking, right? So pretty cool. And this is, again, with the same code that we use up to now, right? So we haven't really added much. And if you look at the code that we have, again, we can go over it, but it's very, very simple. We have a sprite class that all it does, it moves Mario from left to right. That's all it does, right? It keeps track of a little abstractions, but we don't care. And then the magic maybe is here. It loads an image which has the 3 animations. And then there is this function here that what it does, it copies 1 of 3 frames over to the screen. And that's it. There's really nothing else. If you look at the code doesn't have anything in it. It just calls hello update, and hello draw, and that's all it does. So as you can see, again, with this technique and with the power of JavaScript, if you like, we can make a very simple animation, which already looks pretty cool. Really, with the 10 lines of code, is really not much to do. But the power of this is, of course, that we can now move to more classes, more assets, and so on. And so we can do things like Super Mario, right? So as you can see, this is exactly the same sprite, and it's exactly the same asset. But what we can do is create an array of sprites. And then in an array of sprites, we do new Marios in different positions. And then we, instead of updating one, we update all of them here, line 49. And then when we draw, of course, we have to draw all of them. You know, so it's almost the same code. We really making this change takes 2 minutes. But from that, you get from this to this, right? So a lot of more animations. And basically, though, what is happening here, since we are every time we are redrawing everything, it doesn't really matter that much how many different sprites we have on screen, how many different complicated things we have to do, because we are not tracking a bunch of things, right? So if you're doing an animation without using this technique, you will need to track what is behind, what is in front of what, and then we erase all the old Marios, and then put in the background, and so on and so on. Like this, we just redraw everything, screw it, and gets done. It's a price we pay once, but then after that, everything is easy. So let's make a little game then. So going back to the presentation. Okay, keyboard input, right? So what's keyboard input? Is a way to deal with keyboard so you can shoot like in Go pew, 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 right? So, so this is a bit tricky. So here's what it is. So, you know, when you type like your name or whatever you fill in a form, if you press the letter H and you keep it pressed, it goes H, pause, H, 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 right? That is because if it's not like that, it's impossible to type. But that's really sucky for a game. In a game, you want to track stuff like multiple key combination, pressing H with J. How do you do that, right? And also, you want responsiveness. As soon as you press, you want the thing to happen. As soon as you leave it, you want it to stop happening. So the way to do it is actually much easier than it looks. You just use a set. In the set, you add and remove stuff as key down and key up appear. So in the set will contain all the keys that are pressed in every particular moment. It gets automatically updated, again, by using events and abstracting everything. So the code is, again, here you need to know what you're doing. But after using this class here, the code will become very, very simple and very usable. So for example, if we want to make Mario jump, so how does it work? How does jumping work? It's a bit more complicated, but not that complicated. So Mario keeps on moving from left to right. Here it is. But it also needs to jump when I press the key J, like jump. So I have a jump counter. If the jump is 0, so that means I'm not jumping, and the keyboard has the key J pressed, then I will initialize this counter to a specific number which points to this height here. And then every frame, this counter is decreased until it gets to 0. So it will point 1 frame here, 1 frame here, 1 frame here, and so on. Is that clear? So when I draw, I will draw in the first frame, you know, my position, Y position will be my normal position plus this bit here, the 5. Yeah, so it's going to be a bit higher. And then the next frame, I go back, it's going to be 10, so a bit higher. And so it goes up, 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 up to 48. And then it falls down slowly. And then in the end, it goes down to 0. So this creates a, what is it, more or less like 30, 40 frames jump that goes up to 48 pixels. This technique of using counters and then things that happen while the counters count down is very, very common. You need it, for example, for jumps, but you can need it for some special animations. Like, for example, when you start a screen and you have level 1 flashing on the screen, that you do it with counters. When you have a counter, you can have a counter that counts how long your screen is. If you're making a game like, I don't know, which is time-based, again, all counters counting down. This is very, very common and happens a lot, so be prepared. And so what does this look like? Let's see. Go back to our demo. I can show it from here. So here's the code, right? So the keyboard, as I've shown, tracks key down and key up and just adds it to the set. And the sprite has this magic code with a jump pattern. And all the same as remain exactly the same as before. Nothing has changed. So again, I've added 3 lines of code. And here's what you get, right? So this is the normal Mario going around. If I press J, wee. Okay, enough. Okay, but anyway, so as you can see, it's very, very easy to make something that looks actually quite professional and is done with very, very few lines of code again. Moving on, what else do we need? Hit detection, right? Let me see if this is the right key. No! This is when you die. This is the... Okay. Here we go. Okay, so hit detection. So how do we do hit detection? Okay, so here's the main idea. So each sprite has got a box, and is a rectangle which contains the image. And we need to see if your player and the box overlap. And how do we do it? It's actually quite simple, even if it looks a little bit verbose. So if 2 rectangles overlap, then it means that if you take the first rectangle and you go and look at all the 4 angles, at least one of them needs to be inside the other rectangle. Like in this case, sprite 1 has this point here on the top left, which is inside sprite 2, so it's a hit, right? And you can see that if I see if this point is in or any other points are in, if at least one of them is in, it's a hit. So I created a function which is called pointingRect that sees if a point is inside the rectangle, and so I'm looking in this case whether any of the 4 vertices is inside the sprite. This is the function. It's very, very simple. It's just for ifs, basically, for comparisons. And that's it. So another thing that we want to add, again, this to show you this is easy. Barrel is a sprite. We are adding a barrel, so we can have an enemy for Mario. What does the barrel do? It just moves around, but going on the left a bit slower. Doesn't do anything else. As you can see, well, I've added another asset, which is Dead Mario, which, you know, another sprite, which is a Mario with a different thing. So Mario normally responds to jump and moves from left to right. Dead Mario goes pew and just dies. And a barrel moves like this, and barrel asset is an image of a rotating barrel. So again, very, very simple things. So let's put them all together here in code. And we can see here, okay, so the keyboard is still there. The sprite is still the same as before. Nothing's changed. Again, this is Mario. It has a jump. Dead Mario, what it does, it just falls down, you know, with some gravity. And that's it. It doesn't do anything. It's non-interactive. And this is the barrel, again, non-interactive, and it just moves left. And then there is the asset of Mario and the barrel asset, which is based on this, which is, again, very small, but it's a barrel with 4 frames. Okay, as you can see, again, using assets, the way I built them is very, very easy to have sprites with different dimensions, different number of frames. You can choose how many milliseconds per frame very easily. It's all actually quite simple to do. So you can have a lot of variety there. And that's it. So if we see the demo of that and we make it run, let's see what happens. So this is sorry, just a barrel added without any collisions, of course. And the collision bit. So bang. Okay, I need to reload it, so I can actually jump over it if I'm good. But then if I miss it, then bang. Okay. So so there it is. Great game. Okay. So music and sound, they're really missing there, right? It looks like a game, but silent game is just maddening. Turns out these are really easy. So this is how you make a sound. So you do that and it works. That's exactly how I made them here. Again, so you can, it's a bit more complicated if you want to create a whole library of sounds, but not that much more complicated. Again, constructor is the same, the sprite is the same, update, throw, all the same. It's getting long. It's like 100 lines of code for a whole game. Wow. And here you go, right? So we have a sound for the jump and sound for die. And then if there is a collision, then I stop the jump and I make it die and I make dead Mario appear. And that's it. And then when I jump inside Mario, we can see here, I play jump, and that's it. But look how much of a difference it makes in the sort of the feeling of the game, right? Okay. First of all, there is no sound for some reason. Let's try again. This was a bit fast. So as a jump, but just give me feedback, right? It sounds stupid, but these are the small things that actually make a game fun. The other thing is fades. I don't know why games have fades all the time. Again, fades are really easy to do with this, because again, you're controlling every frame, so just print each one a little bit darker. And that's it, game over. So techniques. What else do we need? We need a little bit more, right? So since I talked about Mario, let me talk a little bit more about Mario. In particular, about scenes and Donkey Kong, right? So this is the next thing. So when you have a game, you just don't have the animation with your 5 sprites and wherever it is, collisions and so on. That may be a level, but you have so much more. And that much more, again, makes a game a game. So you have like the title screen, you have the high score, you have when you write in your own name, like if you want to do an arcade game style thing, or you can have small scenes between levels if you want, right? So let's see, for example, Donkey Kong, right? I hope you're a little bit familiar, but it has a title screen. It has a small animation, so when you start playing, there is the Donkey Kong goes around and jumps on these platforms and makes them all twisted, so you have to go up from those. And then before each level, there is this teaser, and then there is the level in which you play, and then after the last level, there is again an animation that tells you, okay, you finish your loop of levels, you can start again. And then when you finish, you can write your name, and then there's, of course, the high score. And on top of that, there are more things. There are demos, there are other bits. So every game, no matter if it's an old game like this or a new game, still has this concept of scenes. So the next thing we probably want to do right now, we have just a small recap. So we have sprites, so we can put stuff on screen, as much stuff as we want. It's really not a problem. We have a way of putting in some intelligence, right? So when you update your sprite, you can make some calculations. So should this enemy throw down a bomb to the player or not? And it's just an if usually, if intelligence. Or you can do other things. Then you have collisions, right? So is the player being hit by an enemy? Is the player's bullet as it hit any enemy and so on? So you do all these calculations here, and then you update your state, and then draw everything and so on. And we have all the tools, all the classes that you need to do that, classes for sound. For music, it's the same as sound, it's just looped. What else? Yeah, we got everything, right? All the hard bits are there. And the only thing we miss is this possibility. So now we have this fantastic game. It's your level, it has everything. Now you want to put a little bit extra. So here's how you do it. So you need to abstract a little bit more. Sorry for drawing box and arrows at 5 p.m. I know it must be annoying, but that's how it is. You can abstract the main loop into a game class that all it does, it takes a scene and calls for the scene the specific updates and the specific throws. And this is so that you can have one canvas, which is one game loop, which is shared across scenes, right? So you may have a menu scene that fades, and then at the same time you can have the game that fades in at the same time, right? So you may want to draw stuff and then merge it along the way. So you need to have an overall game thing that can control this kind of exchanges. Then you have a scene manager, which is a special scene that knows how to allocate scenes. So it knows that if you have a title screen and then you start, you go to the game. And when you finish the game, you go to the high score. And when you finish the high score, you go back to the menu, for example. So this kind of loading logic sounds, well, it's not really complicated, but you need to put it somewhere. That's your scene manager. The scene, again, your levels, all that I've shown so far is a scene. You can have different scenes. So if you want to have your menu, you can't have the same sprites typically as the game. You can have the same logic. You don't want to put the logic in the same place. It's going to be insanely complicated. And again, the canvas needs to be separated. So these are really, really small changes that you need to do, but they won't prevent you from doing a good game. So that's it. And using this technique, I wrote a game which is called Blasteroids, which is a really bad name, but bad because there are at least 10 other games called like that. But I had drawn the logo at the time, so no, not changing it. Okay, what it is, well, I can show you the scenes, right? It has a nice loading screen, and then has a menu, and it has the game itself, and it has, you know, the high score, and so on. So if you want to play it, that's the URL. And I have 2 minutes, so I'm going to use one of them to actually show you a demo of the game. Remember, it's all the code that I've written in the game is pretty much the same as the one you've seen. There's really not much difference. So I'm just going to go. See if it works. Yeah, there we go. So I need to. Okay, so basically what you do with this game is you move around with the spaceship and you shoot at things. And that's it. Okay, so as you can see, I'm moving my thingy down there. And I can pew, 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 pew. Cool stuff. You know, and it's stupid, but since I was a kid, I wanted to write a game like this. It's very satisfactory to kill stuff on yourself. As I was an upset kid. Oh no, I got the bad thing. So this is the bad food. Game, and I guess it's not going to be a high score. Other side, you can do this. I guess I want to and that's it. If you make a nice score, you can go in here. If you hack the API, you can write your own nice score like drop table. Very good. And that's it. So.
Thank you.
So, okay. Yeah.
Thank you.
Okay, here we go. Cheers.
Yeah, thank you.
Thank you.